Good morning, students. Today we are going to discuss about the 8086 microprocessor architecture. So this is the architecture of 8086 microprocessor. Basically, the architecture is divided into two parts. The upper portion is called as BAU unit, which is nothing but the bus interface unit, and the lower portion is called as EU, that's nothing but execution unit, right? And in the bus interface unit, we are having number of segment registers and one pointer register, one summing unit, and instruction queue system. And in the execution unit part, we are having the general purpose register and pointer and index register, and one ALU unit and one flag register. Actually, the 8086 microprocessor is a 16-bit microprocessor consisting of 16-bit data bus and 20-bit address bus and 1 megabyte of memory capacity. Okay, so all the registers which is available in the microprocessor reserve the capacity of 16 bits. That means it can able to accommodate 16 bit of data. Okay, fine. So what is the role of these segment registers? Nothing but in order to store the address location, and this ES is nothing but extra segment, and CS is nothing but the code segment, SS is nothing but the stack segment, and DS is nothing but the data segment, right? So the program related functions will be stored in the code segment, and stack related functions will be stored in the stack segment, and data segment and extra segment will be applicable for the data storage purpose, right? The related addresses, okay? And the IP is nothing but the instruction pointer, and the summing unit is there, right? So that function of the summing unit is nothing but in order to club, that it means it will generate the 20-bit address, okay? Usually the memory capacity of the registers is 16-bit, but we need the 20-bit address, so that address will be calculated by appending the segment registers along with the pointer registers, right? Pointer or index registers. So that can be processed by the summing unit, okay? Fine. The next, the instruction queue system is there. Totally 6 instructions can be simultaneously fetched here, right? And one by one we can fetch. So this will fetch, decode and execute, right? In that system it will work. In the lower part, that means in the execution unit part, we are having 4 general purpose registers called AX, BX, CX and DX. So that can be divided into AHAL, BHBL, CHCL and DHBL, right? So these 4 general purpose registers can be used for general storage purposes, and AX register is nothing but the accumulator register, and BX is nothing but the base register, and CX is nothing but the counter register, and DX is nothing but the data register, right? And 2 pointer registers are there, SP and DP, which is nothing but stack pointer and base pointer, and 2 index registers are there, which is nothing but SI and DA, which is the source index and destination index. And one ALU unit is there, which will do all the arithmetic and logic related functions, right? And one more flag register is there, and the purpose of flag register is to update the information, right? So whenever we are processing any kind of data like addition, subtraction, multiplication, division, whatever may be the thing, right? The results will be updated. That means the flag register consisting of totally 16-bit flag register consisting of total 9 flags, right? So like sign flag, interrupt flag, parity flag, carry flag, auxiliary carry flag, right? So totally 9 flags are available in the flag register. So that is a function of the flag register in order to update the resultant value, okay? Fine. So the totally 14 16-bit registers are available in your 8086 microprocessor, and here the control system is provided for giving the control operation for the entire system, okay? So this is the architectural part of the 8086 microprocessor, okay? Thank you.